conjugate root theorem states that if a polynomial has real coefficients, such as in this example here, the coefficients are real numbers, and we know that there is a root that is complex in nature, then there must be another root which is the conjugate of that root that we already know. So what that's saying here is, for this polynomial, given that 2 plus 3i is a 0, therefore 2 minus 3i is also a 0. And this is only because we have a complex root and real coefficients. If we had a complex coefficient, for example, if that was 39i, then the conjugate root theorem does not apply. We don't necessarily have a conjugate as a root. What the conjugate root theorem does allow us to do, though, is getting both of these roots. We are now very close to having all three roots. We've already got 2 out of 3. That means that this polynomial, z cubed minus 7z squared plus 25z minus 39 is equal to z minus this, so minus 2 minus 3i, and z minus this one, so z minus 2 and minus 3 is plus 3i, some other polynomial multiplied at the end. Okay, because this is a cubic, we have 2. This is going to be linear in nature, and that will make it much easier to find. First of all, what we need to do is to expand this. So z times z is z squared, z times minus 2 is minus 2z, z times 3i plus 3iz minus 2z plus 4 minus 6i minus 3iz plus 6i minus 9i squared. So minus 9i squared is the same as plus 9 with a qx tacked on the end. So let's have a look at what we've got here. Z squares, no other z squares. Minus 2z, minus 2z, so that's minus 4z. 3iz minus 3iz, that cancels out. Dealt with the z's. Minus 6i plus 6i, that cancels out. 4 plus 9 is 13. Our options now are to divide this polynomial by this polynomial to work out what the remaining factor is, using our division of polynomials from extension. Or we can be just slightly a little bit cleverer, because we know that whatever q of x is going to be, it's going to be a linear equation. So q of x is going to be of the form ax plus b. Now when we look at that, 13 times b is therefore equal to minus 39. So therefore b must be minus 3. And z squared times az, sorry, these should all be z's. Z squared times az is going to give me z cubed, so a must be equal to 1. So I get z minus 3 as my other factor. We're being asked to find in the question the factors. So therefore we have z cubed minus 7z squared plus 25z minus 30i is equal to this times q. So z minus 2 minus 3i, z minus 2 plus 3i, and z minus 3.